Okay, so one of the things that any embedded systems engineer should know is C programming. It's an absolute must. There's no second thought about it. And the reason to that is about 95% of the firmware and low-level code is still authored or written in this language. So, Mohammed, do you have inputs on, what are the key parts of the language, key concepts that people should not miss out on?
Hmm. So apart from the basic constructs like for loop, while loop, if, switch cases, I think those are like pretty uh, important in the sense, and plus most of the people would know who have taken one of the courses in their curriculum. But I think
Mm-hmm,
the three main topics which I think drive home the the C in a nutshell would be, first of all, I think structs, because those are like composite data types. I think we'll take the examples later on. Structs would
mm-hmm,
be first ones. Second would be functions, uh, and how the function call works, how they are stacked together, and all of that. We'll also
mm-hmm,
cover that. And the last one I would say is pointers, manipulation of pointers, function pointers, and all of that. So
mm-hmm.
pointer would classify into that. These three topics, I think the amalgamation of them, you'd find that most of the code in Linux and any code base in C, firmware code base, would heavily depend on these three topics. These three key things, if you have nailed down, I think then you can say you have mastered C. And
Right.
for embedded, Piyush, I think I'll also add one. This is for embedded strictly, where you are dealing with low level hardware and you are writing drivers and all. I would say bit manipulation is also another area where I think it's just it's deceivingly simple, but if you know all the concepts around it, I think it will really help your journey in embedded in terms of
Hmm.
controlling all the peripherals and hardwares. Yeah.
Right. So then, if I were to
Hmm.
just reiterate, so you're suggesting, well, structs, functions, pointers,
Pointers, yeah.
and then fourth one is the bit manipulation.
Hmm.
And did I spell this correctly?
Yeah.
Maybe. Yeah. Okay. So what I want to now do is kind of put a picture around why these are important. So in an embedded scenario or embedded systems coding, what happens is you are given a peripheral, so something like, let's say, ADC or something like SPI. So that would be provided as some region in the memory. So certain memory addresses would be um, kind of allocated to SPI configuration and control, meaning that if you write to those memory addresses, you effectively kind of get the SPI hardware to do something. You either read data, you write data, and that concept is called the memory mapped IO, which we'll
Hmm.
come to like later in the series. But under that, what happens is you have a memory region that you have to manipulate to get the hardware to do something. And so what happens is the concept of struct, for example, comes in terms of mapping the different so-called registers to different names. So you
Hmm.
might have within a struct different, let's say ints that map onto this region. That is number one. So you need functions now to be able to go and manipulate these different
Hmm.
integers in the struct. And what you want to do is place this struct or position this struct exactly at a certain memory address, um, depending on what the memory mapped IO mapping is. So for that you need the
Hmm.
concept of pointers, and then obviously within these registers there are bits that affect the functioning of the hardware.
Hardware.
So you need bit manipulation.
Hmm.
So is there anything that I'm missing here in terms of?
No, I think you pretty much covered, the key idea which I wanted to, but I could not, yeah,
Okay,
choose the right
that's
words.
fine.
Yeah.
That's fine.
So I think these all four things provide a nice sort of framework to achieve the goal of our software controlling any hardware. And now that software would, if you have like, let's say, different hardwares, and you have like different pieces of code which control all of them, and they are sort of, laid out in a nice state machine, that ultimately forms a firmware. So I think
Hmm.
these four concepts are very critical in writing any driver or any low level code, which will ultimately
Hmm.
be part of any firmware which is written in C.
Hmm. And you brought up a very interesting
Hmm.
point, which is the firmware usually is a state machine.
Yeah.
It will take your system
Hmm.
from one given state to another. So, yeah, and in terms of implementing the state machine, again, these four
Yeah.
concepts are
So you would
very
see, just one while loop, which is basically operating on all these four concepts in the body, and
hmm,
that's ultimately a firmware, like
right,
very crudely speaking.
fair. So, do you
Hmm.
mind if I very quickly draw a
Yeah.
picture of
Why
that?
not?
So, usually it will be like a function. Uh, okay, let me
Hmm.
just have like function, and then there would be like a, let's say, while
Hmm.
one, for example,
Hmm.
and then there would be like some sort of
Yeah.
switch
Yeah.
which is monitoring the state,
Right.
and then given the current state, well, state and input, let's say.
Hmm.
So in some ways this switch case is doing that, and then what happens internally is you have cases, uh, x,
Hmm.
y, z, default, all of those, and then there will be another functions
Hmm.
here, uh, typically, and this function then, oh, I think I should move, uh, let me zoom this out.
Hmm.
So this function then effectively has the whole struct, pointer, and bit manipulation within it.
Logic sprinkled throughout.
Right.
Right.
And what it ends up doing is more kind of affecting your heart.
Hmm. Hmm.
You go from state of, let's say, taking inputs to
Hmm.
providing outputs. So something of this nature.
Yeah.
Right. So yeah, I think we pretty much gave a good idea of what concepts in C
Hmm.
to be mindful of,
Yeah.
to go after and master. Okay, fair. So maybe we should conclude this lecture and then let's catch up for the next one.